Here we are at, it says question number 3, but this is number 2. This is just the second question. Okay, on the test. There was another one, I cut that out, so that's why we jumped to 3 here. So this will be question 2 on your test. And it's about translations. This is our introduction to translations. Translations basically are things that we do to move a graph left or right, up or down. And it's got to do if we add or subtract a number, a constant, on the outside or the inside of, in this case, what we're using it for this example is these absolute value. But this is the same translations in all math. You'll see it works for everything. It works for quadratics. It works for linear functions. It's going to work for when you get to calculus and pre-calculus. It's going to work for your sine functions, cosine functions. So this is going to be consistent, these translations. And this is just our introduction to translations. So we got this question on the test about this. So what we're using here is the absolute value function. Let me just draw a picture of the absolute value function. I'm going to put a little axis right here. And right there. The absolute value function, absolute value of x, it's shaped like a V. So we got this right here. And why is that? Because it doesn't matter if you plug in a negative or a positive for x, y is going to come out positive. It's whatever that number is in between these two little bars here. That number, this absolute value just gets rid of negatives, basically. So if you plugged in -1, y is going to be +1. If you plug in +1, y is going to be +1. If you plug in +4, y is going to be +4. If you plug in -4, y is still going to be +4. And that's why we get this V shape right here. And this is the vertex. It's supposed to be at 0, 0. The vertex is that bottom of the V right there. And in the original absolute value function, when you plug in 0 for x, you get 0 for y. And that's why the vertex starts right here at what we call the origin. This is our origin story right here. It starts right there at 0, 0. When x is 0, y is 0. But we need to know what moved my vertex over here one spot to the right, is what they're asking me on this question right here. So we need to know how translations move a function. So I've heard other math teachers say they call it inside the house or outside of the house, and we'll just use that. It's kind of the easiest way to describe what's going on here. Right now we're working with absolute value functions. Probably next year in geometry or when you take algebra 2, it'll have a parentheses, or it might be a square root, or a quadratic to the power of 2. And whatever we do on the inside affects the graph differently than what we do on the outside. Like here, we're adding something to the outside of the house. We call it outside of the house, inside of the house. See here, they're adding 2 inside of the house, in that side of those absolute value bars. But here we're adding 3 to the outside of the house. So basically we just got to remember, I've got this nice little visual aid right here that shows what happens if you add 3 on the outside of the house or subtract 4 on the outside of the house. And over here we see these horizontal shifts that come from adding or subtracting on the inside of those absolute value bars. But this is not going to be available in the test. You got to remember what causes your equation to go, what causes your graph to go up or down, left or right. So if you see your graph going up or down, my original is supposed to be right here, the vertex at 0, 0. But something shifted it up 3 spots. And basically every value on here all got shifted up 3 units. So what's going on here, when we add something to the outside of the house, it's directly being added to y right there. It doesn't matter what's going on in here. If we add something out there, we're adding every single thing to that y value. Now, did I lose something? I feel like I lost something on my graph here. We'll just put it back in. Let's put this horizontal axis back in here. Here's 0, 0. X and Y. Okay, so let us see right here. Like I said, if you add something to the outside, it's going to go up or down, and it does kind of exactly what you think it's going to do. If you add something, the whole graph shifts up. If we add something on the outside of the graph, the whole graph shifts up. If we're adding it to the outside of the house. If we subtract something from the outside of the house, all your y values shift down. The whole graph is going to shift down. And what makes it go left and right? Left and right is when we're doing something on the inside of the house. We're adding or subtracting some constant on the inside of the house, which is just an easy way to remember it. But it's got to do with the absolute value bars right here, right? So the weird thing, when it's going up or down, it makes total sense. It does exactly what you think it's going to do. You add, it goes up. You subtract, it goes down. But there's this weird phenomenon with these horizontal shifts when it goes left and right. To make it go to the right, we actually have to subtract something. And normally it would make sense to me, if you see -2, you'd think it might have something to do with this -2, right? But it didn't. It shifted. We see here in red, this graph shifted its vertex from 0 to 0 over to 2. So why did it go to the right when we subtracted 2 on the inside of the house? Well, what's going on here is we need +2. We need x to be 2 so we can get 2 minus 2, 0. So then y would be 0, and we get that point right there. And that's why it goes to the right when we subtract on the inside of the house. And why does it go to the left? If we add something on the inside of the house, once again, if we plug in 2 for x right here, or I'm sorry, -2, if we plug in negative, we need -2 to cancel out that +2. And that would give us 0. If we make x -2, add it to 2, your y value is going to be 0, and that's why your new vertex is over here shifted to the left 2 units. So you got to kind of remember that. Up and down, you're adding or subtracting something to the outside house. If we're subtracting or adding something on the inside of the house, it goes left or right, and it kind of goes the opposite way we think it should. So just remember, you could try and test it out and plug in your x value and see if it makes y 0 down here. So let's look at this graph. This vertex was supposed to be right here at 0, 0. It got shifted 1 unit to the right. So I see here f of x. Somebody asked me the other day, why does it say f, g, h, j? Well, that's what we've been studying for this whole unit, about what are functions. We use function notation because in math, as we progress further and further with math, we're going to have so many different functions. Mathematicians have to come up with some way to categorize them and separate them from each other. So we use the alphabet. We could have f of x, g of x, h of x, j of x. These are all just fancy ways of saying y. And then we're giving our function a name. And then we can talk to other people about it. Or when we go back to look at it, we'll remember which function we're talking about. So f of x, if we graphed f of x right here, -1, it would have shifted down 1 unit because we subtracted from the outside of the house. And then down here, let's look at j of x. If we graphed function j of x and added 1 on the outside of the house, it would have shifted up 1 spot. So it's definitely not A or D. And then how about h of x? It went to the right 1 unit, which you'd think, right? It seems like that makes sense to go to the right +1 if we add 1 on the inside of the house. But what's going on here, we need this +1 to cancel out this -1 right here. So if you plugged in +1 for x, you'd get 1 minus 1. Y would be 0. There's our new vertex right here. Bing, bada bing, bada boom. B is the answer we're looking for right here. We're going to circle this one, g of x. That right here is the graph of g of x. With this vertex hit 1, it shifted to the right because we subtracted 1 from the inside of the house.